very similar to a Singapore Mathematical Olympiad Junior 2021. It's actually problem 9. It's the same structure, just different numbers, different amount of numbers, and different numbers. But problem reads: given 7 consecutive natural numbers, if the product of the first and last numbers is 3960, excuse me, what is the sum of the 7 natural numbers? Okay. Now, I think they use positive integers here, but the natural numbers, sometimes they use a fancy looking in, but the natural numbers is just the set of sometimes called counting numbers. Okay, so 1, 2, 3, ellipsis, of course, means ad infinitum. So we'll put the ellipse there. And anyway, this is the set of natural numbers, and often called the positive integers. Okay. Now, so this part right here just represents a convenient way to write 7 consecutive natural numbers. Some people would start at x and go all the way out to x plus 6, but it turns out this is far more convenient due to some symmetry here. Now, just again, this sum, if we could determine the value of x, we'd essentially be done with the problem. And also, because of symmetry, this sum is actually just is equal to 7x. Kind of nice, and it's kind of a convenient way to write things, because you have 7 occurrences of x, and then also the -3 and -2 and the 1 -1 offset the 1, 2, and the 3 over here. So this sum is undoubtedly equal to 7x. So what we did right down here is directly translate the expression. In other words, this would be the first number. That's the first number. X minus 3 is definitely the first number. And x plus 3 is definitely the last number in that string. Okay. And so again, this is often called in American textbooks just directly translate. You just read it directly, convert from English to a math. I mean, to just math notation. So the first and the last, the product is x squared. I'll let that step out, but that's x squared minus 9 equals 3960, excuse me. Okay, and then when you add 9 to both sides, you get this statement. And I think in the SMO, they expect you to know your squares. They're not going to have a problem like this work out where it's an irrational number, obviously. So 63 is a pretty good try, and it's not easy to verify that by hand. 63 times 63 is 3969. You would know 60 would be close, and you would almost just guess 63 after that. So the answer to this problem is 7 times 63. And let's see, that must be equal to 420 plus 21 is equal to 441. So the sum of all the integers, which we didn't ever have to explicitly state, is 441, and that's definitely the answer. And I like it because we didn't really have to write them down. We do know that this